to build the world's thinnest boombox. How? You're about to find out. So here's what I'm thinking. Traditional boomboxes, like you used to see people walking around with in the 80s, are way too heavy and way too thick. So I want to create something that's way thinner, like ridiculously thin. I'm going to use really thin piezo element speakers, some capacitive touch sensing buttons, LEDs for view meters. On the backside, I'm going to have a really thin rechargeable battery, a Raspberry Pi controlling everything, and of course, no boombox would be complete without a cassette tape. It's going to be wicked awesome. Actually, that's not an 80s word. It's gonna be radical. What do people say in sweatsuits? It's gonna be tubular. Like, it's gonna be funky fresh. It's time to get serious. Now I'm serious. Everything's here, I'm so excited. The heart of the boombox is this Raspberry Pi 02W. This is a tiny $15 computer that's gonna control all the peripherals that we need. In order to get audio out of the Raspberry Pi, I'm using a digital to analog converter. This is gonna provide the analog output I need to drive my speakers. Ooh. I'm gonna use these really small NeoPixel LEDs to act as a VU meter and blink while the music is playing. These are RGB reverse mounted, so these are gonna go on the back side of the circuit board and diffuse through the front. Of course, we need a way to control the music playback, so I'm gonna use these capacitive touch sensing buttons. These are gonna be copper pads, electrodes on the front of the circuit board that I can place my finger onto, and that's gonna register as a button press. For the piece de resistance, we have the Piezo Listen speaker from TDK. Wow. As opposed to a traditional speaker that has a magnet and a cone that vibrates to create the sound, the Piezo Listen generates sound based on what it's adhered to. This thing is less than a millimeter thick. This tiny module has the same frequency response as a traditional speaker, and sometimes it's even louder. It's just amazing, and I can't wait to hear what it sounds like.
Two of these, one on the left, one on the right, and we're gonna make some music.
I've always loved the aesthetic from the 1980s. I've always loved music, and I just love how boomboxes look, their history and their meaning. I just wanted to do something with modern technology and make something that is just gonna blow people's minds and make them kind of rethink what a boombox could be. I kind of searched around for interesting technologies to build with, and TDK had this awesome, super thin piezo speaker, so I wanted to try to build something around that. I thought it would be fun to create a mock-up of my physical board and walk around the neighborhood and see how it resonates with the younger generation. These are the exact dimensions of the boombox that I'm gonna make. Let's go test this out. Hey, have you guys seen a boombox before?
Just a piece of cardboard.
Yeah, but what I'm working on is gonna blow your f***ing socks off.
Okay.
It's gonna have piezo speaker elements, 100 decibels of sound. I'm gonna have a Raspberry Pi on the back with a rechargeable battery. You don't think that's cool?
Sure.
It's gonna be awesome.
Have
You'll
fun with
see.
that.
You'll see. Well, that didn't go as well as I hoped. They'll eventually get it when I show them the final product. The artwork for this project is so important, which is why I reached out to my friend Mar to create some badass artwork.
Hi.
I'm super excited to have somebody that, you know, lives and breathes art. This is the actual maximum size of the boombox. Besides having, you know, the artwork and the electronics, we could make it an art piece and like hang it on the wall.
Okay, awesome. Yeah, I'm down to work with the size. I like to take structural elements, meld them with an organic feel so that there's just lots of visual interest. Like we can totally fill a canvas.
To feel that, okay, you could draw buttons and I could make that be a physical thing that you touch.
But the artwork is only part of the equation. We still have the circuit board to deal with, so I reached out to my friend Mark Hughes.
That is cool. So it'll be huge. You're going for thin.
Yeah. Or
That's cool.
And then imagine like, you know, walking down the street with it.
We would absolutely love to support you with this.
Yay, okay.
My first step was to, little by little, build up my development platform. So I think my test is ready for the Piezo Listen. I have an off-the-shelf Bluetooth receiver that's connected to my phone so I can play sounds from my phone. That has a line out going to my audio amplifier, which also is designed to drive piezo speaker elements like the Piezo Listen, and I have that connected to the Piezo Listen. So once I enable the chip on this board for the amplifier, I should be able to play music from my phone, and if it works, we're gonna hear some sort of sound vibrating all over this table. And now I'm going to enable the driver and see what happens. Oh my God. It works. You could just hear it resonating all over the desk. See what it sounds like with actual music. You can see it vibrating. So this is a circuit board. It's about 1/4 of an inch thick.
Compared to this track, it makes everything they said dull. Life saw the dev and all they killed virus writers. It comes about the challenges.
You can hear it through the circuit board, that's for sure. I think we have a winner. I started putting together what I call a proof of concept hardware. Taking the different modules that I have and wiring them together to kind of create a system to verify everything is gonna work when it's connected together. There was a whole side of software that needed to be handled as well. And that's all controlled by some code I have running on the Raspberry Pi. For the actual music player, I'm using a software package called Mopidi. This is basically a music server where you can load music onto local storage, or you can configure it to stream internet radio streams, podcasts, Spotify playlists. It's just a really cool open source package. What I have here is kind of the front end for the music player, telling which button we want to correspond to which action. The proof of concept circuitry is complete. Now I can focus on actually creating the circuit board layout for the real deal boombox. The prototype basically is this intermediate step between the proof of concept and the production unit. I could take all of the different designs and electronics from the proof of concept and put it onto a single prototype board. I am done with the prototype. Here is the battery, Raspberry Pi, on-off switch, a digital to analog converter, our audio amplifiers, capacitive touch. These are all of the components ready to go for the prototype build. I'm gonna pack these up and send them over to advanced assembly. When the prototype board came back, I went to work to test all of the different pieces to make sure everything was working well together. Interesting is actually something of this size that almost feels like it's warping a little bit. I wonder if we're gonna need some sort of mechanical stability so it doesn't bow. I had to solder my Raspberry Pi onto that prototype. I attached the battery, the piezo-listening elements, tested the capacitive touch sensing buttons. Everything worked without having to modify any of the electronics. Oh, look at that. I can't even describe how excited I am about this. This might actually work. The idea of this boombox ended up being way more ambitious than I actually thought it would be. Design of the production board took a really, really long time. I have this page of notes that I'm working on, this page of notes that I'm working on, making progress, working with Mar to integrate all of the artwork, working with the circuit board fabricator to make sure that we can do some really neat things, controlled depth milling via in pad, laser drilled vias, multiple layers of solder mask on the front side for artwork, and then designing the actual circuit board layout took many, many hours. But I just kept thinking, how cool was this thing gonna be when I was done? I never thought this day would come, but I finally finished the production layout for the world's thinnest boombox. Royal Circuits and Advanced Assembly have my design files for the production unit. Let's go see how they're doing.
Oh, that looks nice. It's so cool.
Once I got the production circuit board back, I still had to do some post-production assembly before we could actually go and use this thing.
Here we go. I'm gonna put on the Raspberry Pi in the middle.
I wanted the Raspberry Pi to be as flat and low profile as possible on my board, so instead of using a traditional type of interconnect like header pins, I decided to solder the Raspberry Pi directly to the circuit board.
Raspberry Pi is in.
I did some continuity testing to make sure that the connections I needed were properly soldered and properly connected to the boombox circuit board. The next step was to take my lithium polymer battery and stick that down onto the board with double-sided tape.
So I'm gonna put my SD card into here. I'm gonna power it up and see if it turns on. It all works.
The next step was to mount the TDK piezo listen elements directly to the boombox. To do that, I used some special double-sided adhesive and very carefully laid down that piezo listen element onto the board. To give the circuit board a little more structure, I designed a frame to go around the backside and basically protect all of the circuitry. The total thickness of the boombox, including the main circuit board and the frame, is 0.45 inches. That's less than half an inch, which I think is pretty good. And as a final step, I took two small 10mm diameter neodymium magnets and attached those to the backside of the circuit board. Using a specially modified cassette tape, you can actually attach that on the front of the circuit board, and you can even use the cassette tape to turn on and off the boombox. This isn't your grandmother's Bluetooth speaker. This is a fully custom portable sound system. Every boombox needs one of these. I wanted to test the final product with some people that would really appreciate it. So I made a few important phone calls. Yeah, could you do Sunday at 10? Okay, we'll see you there. Thanks, bye.
That's actually pretty tight, actually. That's actually really tight. This one's dedicated to all the hackers. Yo, even out, settle scores quick. Our disaster recovery requires even more discs. Put your bites up, prove it or you forfeit. Got my C64 and we blew it into orbit. M Bison with 8 straight perfects. Overvolt emotions make hate break circuits. In case you heard, it's a name fake service. Optimize our runtime to escape verdicts. Got an integer scope flow that they can't sign. Passing code, didn't sanitize command lines, landmine. So before they'll see me after, I'm advice star, courage, woke plus velociraptor. Don't prove we're human unless we really have to. My team built schemes that destroy, recapture. Hate what they see. Finish this chapter. By the way, we're not any geeks, we hack into NASA. Drink all the booze, hack all the things. Drink all the booze, hack all the things. Drink all the booze, hack all the things. Got this vodka and this Red Bull, they still give me wings. So we drink all the booze, hack all the things. Drink all the booze, hack all the things. Drink all the booze, hack all the things. 0 through 3, we're in every single ring. Hack all the things.
Yeah, well, good luck, man.
The beauty of this project was being able to work with so many talented people across art, music, and engineering. And I'm really happy with how it all came together. And now we have the world's thinnest boombox to sit along with all of the past boomboxes out in the world.
What's up, everyone?